9.2 or unit SP2 is scatter plots. We're still working with scatter plots, but now we're going to focus on a line of best fit and using that line to make some predictions of what we think would happen. So a line of best fit, or you'll notice it's called a trend line because it's going to, they call it a line of best fit. When I went to school, it's called a trend line, but now they call it a line of best fit. It's showing you which way the pattern of the data is going. That's what a trend line or a line of best fit is. So a scatter plot shows, if a scatter plot shows a linear relationship. When I read that wrong, I'm like, I don't know what word I'm supposed to put there. So if a scatter plot shows like a linear, meaning that you could draw a line of best fit or a trend line can be drawn because it is the best description of how the points compare to one another. Now, here's where some of you guys really get confused. This is a line of best fit. You'll notice I did not call it a perfect fit. It's a line of best fit, and that's because the trend line is, the trend line should lie as close as possible. Apparently I put that in there. Should lie as close as possible to the majority of the data points on the scatter plot. So as we look at this, when you're looking at it, you're trying to split the data as evenly as possible above and below your trend or your line of best fit. So hopefully you can look at these and be like, well, that one is terrible or that one is good or whatever. Number one should be obvious. This is a terrible representation. You should be able to tell that our data is actually increasing, but our trend line shows that our data is decreasing. So it says, explain if the line drawn is a good example of a line of best fit. No. And I would put going the wrong direction. Our next one, I would say yes. You can see that it's about straight down the middle of your data. Some's above it, some's below it. So I would say yes. And I would just put splits data evenly. Number 3, while this does show what direction the data is going, you can see that almost all of my data is lying below my line of best fit. So this is not a line of best fit. It's a line of fit, but it's not even close. So it should be cut. I probably could have pulled that up even a little bit more. It should cut about right through there so that it's, about has the same amount above as it does below. So, and they may even do it more like that. I can't draw a straight line. So this one would be no. Data lies below the line. And then our last one, again, would be no because our data lies above the line. All right, so here's how we're going to do this. You guys have already written these before. You've already written equations for lines. It's the same thing. So the first thing we're going to do is find B by using the y-intercept of the trend line or line of best fit. So it may not hit any points. It doesn't matter. That's why it's called a line of best fit. The line, the equation we're going to give is just the equation of the line that best fits our data. So you don't have to hit any data points. You're just going to use the line they've given you. You're going to forget that any of those points even exist, and you're going to look at the line and use that line. So we're going to choose any 2 points from the line of best fit. So from this line of best fit. And then we're going to find the slope or our rate of change. Rate of change, finding slope is fun. So if you need to do this again, this would be y2 minus y. Well, this one you're going to draw your triangle. You could still do y2 minus y1 over x2 minus x1, but you're going to draw your right triangle. So, and you'll notice down here it says, since it is a line of best fit, it may not hit any graphed points. So use your knowledge of the graphed line to find the slope or rate of change. And then we're going to use our answers from steps 1 and 2 to write an equation in slope-intercept form after we found our M and our B. So here's our first thing we're going to do. First step, find B. Well, my line is right here. That's where it starts, is at 8. My slope, again, I do not care about any of the points graphed. I'm only going to look at these specific ones. So it hits here. It hits here. So it does actually hit a point. Great. Sometimes it does, sometimes it doesn't. It hits here again, and it hits here. I only need 2 of those. And we're not finding distance right now. We're finding a rate of change. So I dropped 1. So I drop of 1. So a -1 over, and I went on 1, 2, 3. And again, I looked at my scale to make sure that it was just counting by that. So now I found my M and B. Now I'm going to take those and I'm going to replace it into Y equals M X. Remember that X goes off to the side or on top, never on the bottom, plus B, or 8 in this case. All right, our next one. Our B again, starting at 20. Our slope, our first point is here. Now you'll notice I didn't hit a point there. I didn't hit a point there. I didn't hit a point there. I don't care. This is why it's called a line of best fit. It may not hit any of your points, but that's the best line you could draw that's going to be accurate for this data. So this is going, this time we're counting up here by 10. So I went up 10 and over 3. So my equation would be Y equals MX plus B. This should not be new to you. We've been doing this since October. All right, so now we're going to take it a step farther and make some predictions. And so you have to really pay attention to, this is where we struggled with functions as well, because you have to pay attention to our axes, what they mean, what it is we're actually looking at. So it says, use the scatter plot below to answer the questions. Pay attention to the scales. So right here, we're looking at time and we're looking at elevation. So I'm going to actually skip this very first one and come right here. What do my X values mean? Time in minutes. So each X value, it represents minutes on this graph. Now each Y value, it represents some type of total. I've already discussed that with you, that it's always a total. In this case, this is total elevation. Looking at your scatter plot, you should be able to tell, and they have given you a pretty good line for line of best fit, not perfect fit, but best fit. Now we're going to find our slope, and then we want to know what it means. Well, remember that our slope is our change in Y over change in X. So I'm going to find my slope. My slope change, or my change in Y is 100 feet every, let's see, my next point is right here, 4 minutes. So it would be 100 over 4, which would actually simplify to 25 over 1. Well, X's are on bottom, Y's are on top. So this would be 25 feet every minute. So that's what my, what does it mean? It means feet every minute is what we're covering, feet per minute. Our B, our initial value in this case is 900. What does it mean? Where they started, or elevation started, starting elevation. So our equation would then be Y equals, there's my M, so 25x plus 900. Ooh, I made a mistake. My slope is going down, so this would be a drop of 25 feet every minute, or a drop of 100 feet in 4 minutes. So I say that because I lost it right there. Okay. So it should be a drop of 25 feet every minute. So here's where their prediction comes in. Now that we have our equation, and we've done similar to this before, but the reason this is a prediction is because it's a line of best fit, not perfect fit. This says, predict the elevation. Well, which one represented my elevation, my X's or my Y's? In this case, it's my Y's. So predict the elevation, the hikers would be after 15 minutes. So I would have Y equals -25. My minutes were my X value. So I'm going to replace this 15 with X plus 900. So we're going to do -25 times 15 That's negative 375, and then we're going to add the 900 on there. So after 15 minutes, we would predict them to be about 525 feet in elevation, which 525 would be like down here. So if you think about it, I don't know, probably pretty close, pretty accurate. All right, so I'm going to do 4 with you, and then 5 will be on your own. So first thing I'm going to do is I'm going to look for my x values and my y values. So my x-axis is hours worked. So x values are going to be hours worked. Y values are going to be dollars earned. So money earned. So this, first we're going to find our slope or our rate of change. And rate of change is always a change in y over change in x. So this is money over hours. That's what our rate of change represents. So I have a point here, and then it crosses again, not till right here. And then again, man, that one's kind of a tricky one. So let's see if it should cross again. Yep, right there. Perfect. Just making sure I did that right. So now we're going to look at this. We're going to find our rate of change. I'm not counting by 1s here or 2s here. I'm actually counting by 8. So I went from 24 to 48. So I went up 24 and over 5. So I would put it in as $24 every 5 hours. That's not a very good paying job, but 24 divided by 5. So it doesn't change. So this is saying you get $24. So and again, it's going to be money over hours. That's what my slope represents. I make $24 every 5 hours. And if you really wanted to simplify it, it would come out as 4.8. So $4.80 every hour. So money per hour. That's what our rate of change is. Jim needs to get a different job. That's not a very good paying job. All right. Our initial value in this case, my line starts at 24. So this tells me that even if he worked no hours that day, maybe he's on call, so that's why it's so low. His base pay is $24. So base pay, no matter what, he's going to earn $24. And then it's just going to increase from there. All right, and then from there, our equation would be y equals m, and I don't care whether you use this m or this one. I'm going to use $4.80 times x plus my base pay. So it says, use your equation to predict the money. So I'm missing money, but I have my hours. So it would still be y equals $4.80 times my hours, because x represented my hours worked. And I'm going to add on that $24 I get just for showing up to work. And maybe, well, nope, it's not. So 4.8 times 18. So if you worked for 18 hours, you make $86.40 plus you get $24 as a base. So your total money here would be $110.40. All right, try number 5 on your own.